So now with that, now that we did go through a lot of important TypeScript fundamentals, though only of course here by going through all that theory, it's finally time to get our hands dirty and to build some stuff, some React project to be precise, so that you see those core concepts in conjunction with React, and you also understand how you can use TypeScript with React. So that's therefore what we'll do in the next course section. So now that we covered some crucial TypeScript essentials, let's get started with connecting TypeScript to React. And for that, in this section, we're going to build a basic demo project which allows you to set and manage the goals you have for this course. And it's this demo project that will allow us to dive into all those essential, crucial concepts you must know no matter which React app you're building with TypeScript. And therefore, in this section, we'll explore how to work with components and props and TypeScript. We'll take a look at how we can handle events when using React with TypeScript. And of course, very important, also how we can deal with state. Last but not least, we'll also explore how we can get user input with help of forms and refs. And therefore, by the end of this section, you'll have a solid React and TypeScript foundation, and you'll be ready to dive into more advanced React and TypeScript features thereafter. Now, in the last section, we got started with TypeScript, though only in theory, of course. Now there, we mostly worked in this code editor, but I did mention this compiler, which you can invoke by running npx tsc, at least if you did not install TypeScript into your local project, which we didn't do in that section. Now you can use that compiler to then target a specific file, for example, firstapp.ts, which is the file we worked on there. And if you then hit enter, this file gets converted to a JavaScript file. And before that conversion happens, TypeScript will actually check that file for errors, though as you saw in the last section, most errors, pretty much all errors, can already be seen right in the IDE before you even invoke the compiler. Nonetheless, you then get this JavaScript file, which then is the file that you could include in the browser, because that file then doesn't contain any TypeScript code anymore. And as you can see, if you take a look at that code, the code even gets converted such that it works with older JavaScript versions in case you're building for an older browser. Now, in this section, that's going to change though. We're not going to invoke the compiler by running this npx tsc command anymore. Instead, now we're going to switch to a React project where the compiler will be part of that project and where it will actually be part of a build pipeline that can be invoked when we want to prepare our overall application for production. Because as you might know, React code, even when not using TypeScript, also must be converted such that it works in the browser. Because this JSX code, which you write all the time when working with React, doesn't work in the browser like this. So the code must be converted and also, as it turns out, optimized anyways, and therefore this TypeScript compilation will now just be another part of that build process. Therefore, what we'll do for this section here is we'll create a new project by running npm create, for which you need to have Node.js installed on your system, and then use the vite build tool for creating that project, and also then later inside of that project for running the dev server and for building the code and optimizing it for production. And here I'll ensure that I'm using the latest version. And I'll name my project React TS basics, because that's what we'll explore in this project and this section. If I now hit enter, I get this prompt to choose from a list of templates. And here, of course, we want to build a React project and we want to build it with TypeScript. So it's this first option here in my case, which I'm picking. And with that, if you then open this project in VS Code, for example, you get a typical React project structure with some React code files, now just named .tsx instead of .jsx, because we'll write JSX code, but we'll also use TypeScript features, as you'll see soon. But you'll also notice, if you take a closer look at this project, that there is a tsconfig.json file. And that, in the end, is a file that will configure the TypeScript compiler. You can add such a file to any TypeScript project, no matter if you're using Vite or not, but it is then a file that will be used by the compiler to basically configure how the TypeScript code will be compiled. For example, which target JavaScript version should be targeted, and therefore how much your code should be converted to also run in older browsers. Here, for example, we're targeting a relatively recent JavaScript version because here we might not be targeting super old browsers, where React also might not work. So that's one file we'll take a closer look at soon. In addition, as mentioned, it's now this Vite build tool which will automatically also convert this TypeScript code to JavaScript code. So as a developer, we'll just write our code in these code files, and then once we're ready to ship our application, it will be this build command that we need to invoke. And there you see that it's actually the TypeScript compiler that's invoked, but it's a predefined command that was created by Vite here. And that TypeScript compiler is now installed locally in this project here. So it can be invoked from inside this project, even if you did not install it globally. And then thereafter, the Vite build process is invoked. And for example, for the dev server, it's a combined build workflow, fully powered by Vite. Under the hood, it will compile the TypeScript code and start up that development server where we can preview that application we're working on. So all that is taken care of by Vite, and we don't need to invoke the compiler manually. Instead, we just need to run the commands that are defined here in the package.json file. And with that, let's take a closer look at this tsconfig.json file before we then, thereafter, finally get started writing some React and TypeScript code. So before we'll write any React TypeScript code, let's explore this tsconfig.json file. Now, as mentioned, this file contains the, guess what, configuration for TypeScript. For the TypeScript compiler, to be precise, though this tsconfig file will actually also be read and picked up by the IDE we're using here, by Visual Studio Code, and Visual Studio Code will adjust how it shows errors to us and when it shows errors to us based on the settings we have in this file. Because it turns out that you can configure TypeScript to be pretty strict, mostly, but not limited to this strict true setting here, which enables strict mode, which enforces more rules and more type-related strictness. And therefore, of course, when that strict mode is enabled, as it's the case here in this project, TypeScript is stricter and the IDE, Visual Studio Code, shows errors earlier than it would normally. By the way, since it is possible that your tsconfig file, when you create a new project, looks slightly different, attached you find my tsconfig file, and attached you actually find my entire project setup, also a version on Code Sandbox, so that you can also follow along with exactly the same project setup and the same code I have. And even if you do have the same tsconfig file as I do, I still recommend that you use that attached starting project, because in there I edited the src and public folders to include different files than the default project has. For example, different styles, which we will use throughout this section. So you should at least replace your source and public folders with the attached ones, so with the ones you find in the attached starting project. But back to the tsconfig.json file. In there, as mentioned, we can, for example, set TypeScript to be stricter, so to be less forgiving. But of course, there also are a bunch of other options. And the good news here is that as a TypeScript developer, as a TypeScript React developer, you really don't need to understand all these options, because there are a lot of niche and advanced options here. Some options like this module resolution option, which are really only important for that build tool for Vite, which we're using under the hood. And pretty much all these options are only important for the build tool, you could say. And then some other options like this lib option, which, for example, controls which built-in types are available in this project. For example, that we got some default DOM types available so that we can work with DOM elements and we don't have to write the types for such elements when we work with them on our own. But in general, you can keep that tsconfig file as it is. You could disable this strict mode if you want a more forgiving, less strict mode, which can be helpful if you are facing a problem with some code where you just can't come up with the right type. But here for this course, we'll keep this set to true. And therefore, with that, we can finally leave that and ignore this tsconfig file, and instead, in the next lecture, get started with writing some code. And therefore, with that, let's get started. And the first step to get started here is to actually run npm install. No matter if you created a new project or if you're using my attached project, only on Code Sandbox, you don't have to do that. There, if you are using the Code Sandbox starting project, everything is set up for you already and you don't have to run any code. But locally, you should run npm install and then thereafter also npm run dev to start that development server. And with that, you should be able to visit localhost 5173 and then see Let's Get Started on that page. And I'll keep that development server up and running until we're done developing, which we aren't yet. Now in this course section here, we want to build this goals app here, where we can manage the goals we have for this course. And whilst this, of course, will be a relatively basic React app, it will be an app that allows us to explore those core React and TypeScript features and how we can connect those features. Therefore here, in this project, I actually want to start by adding a new components folder, because we'll need a bunch of components. And then in there, a course goal.tsx file, which should eventually contain a course goal component. Now it is .tsx, of course, because it will contain some JSX code, but we're going to use TypeScript. And the appropriate extension for that is .tsx. In a vanilla JavaScript project, you would have JSX, here it's TSX. In that file, we should then export a component function as our default for this file, for example, just as you would do it in a normal React project. And by the way, this course assumes that you do have basic React knowledge. If that's not the case, I recommend that you go through my crash course, to which you find a link attached. Of course, I then also got the React the Complete Guide course, at which you also might want to take a look to learn all about React. But you can get those basics from that crash course. So here I assume that you know these basics and that you, for example, know that we can create a component in React like this by defining and exporting a function. And of course, React, as you also should know, is all about creating and combining such components. So here I want to be able to output a list of course goals, and every course goal could therefore be such an article, the default built-in article element, which then for styling purposes contains a div, where I have a h2 element which should output the title for the course goal, below that a short description, and then below that a button which we can click to delete it from the list. Now at the moment we don't even have the logic for adding it to some list, but we'll eventually get there and we'll eventually also make it deletable. So that's the general structure of this component. The goal, of course, is to use this component in the app component for now. So here we want to import course goal from, and then it's from components, course goal, and then here for Vite projects, it is considered a good practice to add the file extension to these imports, though it would work without that as well. And with that imported, we can output that here in this app component. There, I just want to render a main element, and then here, for the moment, I'll just output the course goal component like this. Not yet as part of a list, instead as a standalone component. Though, of course, we could output 2 course goals if we wanted to, but let's get started with 1. If we save that, we should see something like this on the screen. And of course, whilst that works, this is a component that's not too useful yet because it's not configurable. After all, title and description are just placeholders here. Now, how do we change that in React? With help of props. And that's now the first time where we'll have to write code that's different from vanilla JavaScript React projects. Because now that we're accepting a parameter here, we should also define the type of that parameter, so that we get this extra type safety when writing the code, and that we get the extra auto-completion, and we know which properties to find on this props object. And at the moment, we got no information about that. Instead, at the moment, it's assumed to be any, and we're actually getting a bunch of warnings and errors here, one of them being that it is implicitly of type any, because we haven't defined any other type for this parameter, and therefore then the default type that is assumed is any. And we're now getting an error because of that, because we did set up strict mode for this project, because strict is set to true. And one of those extra rules that's enforced by setting strict to true is that you must not have untyped parameters. So this implicit any is not allowed. You have to explicitly set a type here and make it clear which type of value can be expected here. And that's therefore the next question. Which kind of value can we expect here? So here's our first opportunity, and actually the first place where we have to connect our regular React code with some TypeScript logic. We have to define the type of these props. But what is the type of props? Well, in the end, this props thing, which is automatically passed to every component by React, is just an object. It is an object, in the end, that contains any key value pairs of our choice. In the app component, we can, for example, add a title prop to course goal. And then give it a title of Learn React plus TS. And we can add a description prop, a description attribute, you could say, which should also contain some text here maybe, where the text could be learn it from the ground up. That's how we add props. And as you know, these key value pairs here are then added as properties, as key value pairs in the end still, to this props object. So here in course goal TSX, we can set the type of props to an object type where we expect to have a title property, which will be of type string, and a description property, which will be of type string. So that it's this object type which we're expecting for our props. Now I'm still getting an error here, mostly that I'm declaring it but never using it, but we're going to change this now. Of course now we can also use object destructuring here, so that instead of then using props.title and props.description, we replace it here in the parameter list with a pair of curly braces, opening and closing. But here on the left side of this colon, this is now not a type definition or anything like that. Instead, it's the standard JavaScript destructuring syntax where we can now extract the title and description properties from that incoming props object. And then we can use title down here and description down here to output both title and description. And with that, we can save this. And if we go back, we see our text here. And therefore, in the end, as you can tell, setting this type is rather straightforward. We just create our own object type because it's our component and we control which data we expect to get there. So we set up an appropriate type and assign that as a type for this props object. And then we of course just have to make sure that we pass in the right data. But TypeScript actually helps us with that. If I would now try to add an ID here and set this to a number, for example, like this, I would get an error here that my prop type here, which is this object, is not assignable to, in the end, a type that also has an ID property. Because that's the case. This object type here does not have an ID property, so trying to set such an ID prop correctly fails. And that's that extra type safety we get thanks to using TypeScript in our React project here. So that's how we can define the type of our props object, and that's a perfectly valid approach. Now, defining this type in line in this parameter list can make this code a bit hard to read though. After all, we got a lot of curly braces here, and if this would be a more complex object, we would have to write quite a bit of code here before we get started with the component logic. That's why we might want to use another feature which I introduced in the TypeScript basics section in this course. We can create a custom type, a type alias. And we can cut this object type definition here and instead create our course goal props type here. The name, of course, is up to you. And then store this object type in there. And now use course goal props as a type for this props object. And that makes this code way more readable, of course. Alternatively, you could also use an interface, like this. And that would also be perfectly fine. You will see both approaches out there in the wild in React and TypeScript projects, and whilst you will read a lot of opinions on that, In the end, it will come down to your personal preference, which approach you prefer, unless you're working on some library which you plan on distributing to other developers, in which case you might want to prefer an interface because it's a bit more extensible, as shown in this TypeScript basics section. But in your own project, it really comes down to your preference. So that's one thing we might want to do. Outsource the type like this. Outsourcing the type like this definitely makes sense. Now, of course, as a React developer, you might know that actually every props object also has this special children property, which is populated by React. The idea behind this children property is that we can wrap our component around some other JSX code and then use that wrapped code inside of the component. And we'll use it in just a second. And now the problem here with our course goal props is that we don't have the children property in there. And indeed, therefore, if I would try to extract children from my props, I would get an error here. That property children does not exist on my props type. And this is technically correct, but of course, as mentioned, in theory, every component receives that children prop. Well, the thing is, if this component here doesn't use the children prop, you also don't have to set up a type that theoretically gets this children prop. Because if your component is used like this and is not wrapped around some JSX code, the children prop will be undefined, so you won't be able to extract a renderable value in the end. And therefore not being able to extract it at all makes sense. But if you want to use the children prop, let's say here course goal should be usable such that we actually do wrap it around this description instead of setting the description as a prop. If that's our goal, we of course have to tweak our type. And we can do this here by now getting rid of description, because I'm not setting that prop anymore, I'm just setting the title. And we now have to add this special children prop. And the question now just is, what's the type of that? Is it string, because this here is some text? No. This here is some text, but in the end it's JSX code. It could be wrapped by a paragraph, for example. That would be possible. So it's not just text, it's actually JSX code. And what's the type for that? Well, the type is a special type that's built into React, the React node type. To be precise, it's not built into React, but it's distributed as part of a type package that was pre-installed in this project. If you take a look at the package.json file, you find these types packages here under dev dependencies, one for React and one for React DOM. And these packages contain extra type definitions that you'll probably need when working with React and TypeScript. For example, this React node type, which I'm now importing from React, even though technically it's from that types package. But you can kind of say that it's merged behind the scenes. Now, this is not an object or a function or anything like that that we could use. Instead, it's a type, and therefore it's also a good practice to add the special type decorator here in the import statement. This is a special decorator that you can use in TypeScript projects to make it clear to the build tool, for example, that this is an import that can be removed in the code that should later run in the browser, because the browser won't be able to deal with types anyways. Either way, with React node imported, that's now the type we should set for children, because anything that's renderable in the end is such a React node, or is of type React node, you could say. So this JSX code here is of type React Node. And therefore now with that, we re-added the children prop, and we can now extract the children prop, and of course, down here, also output the children prop. And I did now replace the entire paragraph with it because in the app component, I actually added these paragraph tags around my description text. With that, if we save that, this looks as before, and it still all works without any errors, neither here in the IDE, nor in that terminal where the dev server is running. And that's therefore how you can get hold of that children prop again if you need it. There also is an alternative approach though. And for that, I'll actually define this with help of the type keyword, because you can also use another type provided by React and that types package. And that would be the props with children type. It's also a type, which you therefore might want to decorate like this. And it is actually a type that will give us a props object that has this children key, which is why we can extract children down here without getting an error. As you can see, I'm only getting an error for title, but not for children. And you see that children here is of type React Node. The exact same type we manually set up here. But of course now it's only a props object with children and not with title anymore. That's why props with children is actually a generic type which only works in conjunction with another type. And that other type is your more specific props object that contains all the other props you want to accept here in this component. So in this case, for example, an object with a title property which is of type string. And that would be an alternative way of defining our props here with that special props with children type. It is totally up to you if you prefer this approach or this approach. The important thing just is that you know how to also get hold of those children if you need to. So now at this point, we learned a lot about typing props, but it is important because you're going to work with a lot of props when using React and TypeScript. There's just one last alternative syntax, which I also want to explore together with you. Because of course, defining a functional component like this with the function keyword is just one possible approach. An alternative, if I copy this return statement and comment this out, would be to create a constant, let's say course goal, and then export that as a default, for example, and set the value of this constant to an arrow function. And then in here, we can return our markup and receive our props here. Of course, we can now type the props just as we did it before. We can add our type like this and then extract title and children, and everything works as before. So that's absolutely valid. But when using this syntax, where we create a constant or variable, and we then assign a function as a value like this, when we use this approach, we also have an alternative way of assigning our type. We can add a type assignment here to the course goal constant in this case, and set the type to FC, which is also imported from React and which is also a type. Now FC stands for functional component, and this tells React that the function we do assign in this variable or constant will be such a functional component. And FC is actually also a generic type, where the connected type is the props type. So now we can set course goal props as a connected type because this FC type internally is built such that it's now this type that's used as a type for the props object, which is why now extracting those props again works without errors. And that's simply another alternative syntax which you should know. There is no better or worse syntax here. It really comes down to personal preference, but you will also see this syntax in a lot of projects, which is why you should also be aware of it. With that, however, I'm actually going to comment out this code and bring back that other syntax, which I'll use throughout that course, and move that up here, though actually below the type, so that that's the syntax I'll use, but either approach is fine. I'm now just going to remove that FC import because with that approach, I'm not needing it anymore. So now that we spent a lot of time on props, I now got a little exercise for you. I want you to build a new header component, which can be used here, which should take two input values. The first value should be an image prop, which should actually receive an object as a value. An object where I want to have a source property, which should point at this image in the assets folder, this goals JPEG image, which you can import with the import statement because that's supported by that underlying build process. So we can import the goals image from diving into the assets folder and then goals JPEG. So that's the value for the SRC image. And that in the end is just a string because it will be a path to that image. And the second value here should be an alt text, which is a list of goals, because that's in the end what will be on that image. So such an image prop should be passed to header, and then header should also be wrappable to be wrapped around the H1 element where I say your course goals. And your task now is to build that header component in a separate file and configure it such with TypeScript so that it can be used like this. Here's a short pause for you to pause the video. Thereafter, we'll tackle this together. So, did you succeed? Let's build this header component together. For this, in the components folder, I'll add a new header.tsx file. And then in that file, we want to export a new function as a default, which is called header. Now in here, I want to output the built-in header element, and then in there have an image, which must be populated with help of the values that are set in this object. And I, of course, also want to output the wrapped content. So below the image, I want to output the special children prop. So, of course, to make this component work, we need to accept props, and we need to type these props. And we can use one of the approaches I showed you over the last lectures, and it's up to you which exact approach you prefer. I'll go for a custom type with the type keyword and set up my header props as an object where I expect to get a children prop, which must be of type React Node. And that is imported from React then, and it is a type as mentioned. Therefore, I'm marking it as such with that special type keyword. So that's the first step. The next step is to make sure that we also accept such an image prop and define the type of that image prop. Well, and the type in the end should be an object type, where the object should have two properties, src and alt, where both properties contain values of type string. So back here in the header.tsx file, I'll add this image property and set the value to an object type, which you can do because in here we're defining types, and an object type is a standard type, as you learned in this TypeScript Basics section. And this, in the end, nested object type here should then have the src property, which will be of type string, and the alt property, which will be of type string. Well, and that's now the shape of my header props object. So I'll set this as a type for props. And with that, we could now access props.children, or to make it a bit easier for us, use object destructuring here to pull out the image and the children prop, and use just children down here. And then on the image, we should set the source attribute, the source property of the image, to image.src, and the alt attribute to image.alt. And since we're using the same names here, alt and src, on that image object, we can actually even shorten this if we want to, and just distribute the image object, which does contain this source and alt property, onto this image. That's a general React shortcut, which you don't have to use, but which you can use to make your code a bit more concise, which will simply take all the key value pairs in an object and spread them as props, as key value pairs, therefore in the end, onto an HTML element. With that, we get the finished header component, and back in the app component, we therefore now just have to import header from components, header tsx. And with that, this should all work. If we now save that, we should see this header here. Okay, at this point, we really spent a lot of time on components and props. It's time to move on. And which other React concept is extremely important and is getting used in pretty much all React apps? State. Because whilst components are those reusable building blocks, state is what makes a React application truly dynamic and interactive. Because state is the thing that in the end leads to different UIs being rendered, for example, in response to button clicks. And speaking of that, here I will add a button and will later add a complete form, but for the moment it's just a button, where I'll say add goal. And of course the goal now is to add a new goal whenever this button is clicked. At the moment with some predefined dummy data, later with custom data. So in order to make this happen, I'll start by adding a nested function in the app function, which I'll name handle add goal. The name is up to you, but this is a common convention for naming your event handler functions, so functions that should be triggered upon some event. An alternative would be add goal handler. You also see that a lot, and in the end the name is up to you, it just should describe what the function does. And here the goal is to dynamically add more and more goals to this app. So therefore, I'll add the onClick prop to this button, the built-in onClick prop, and point at handle add goal here, so that this function is triggered whenever this button here is pressed. And in here, I now want to generate new goals and then dynamically output them on the screen. And for that, as mentioned, we'll need state. And we can register some state here in this app component, of course, with help of the built-in useState hook, which must be imported from React and which is now not just some type, but instead a real function that we can execute. Now, as you know, useState returns an array with exactly 2 elements. And the first element is the current state snapshot for this current function execution cycle. The second element is a function we can call to update that state snapshot. and to trigger this component function to be executed again, therefore, because that's how React works. So here I want to manage some goals, and therefore my initial state could be an empty array. And then here in handle add goal, we can add the logic for manipulating this array with help of set goals. But before we do that, there's one important problem we should solve, or one improvement we should make here. If we hover over goals, we see the type of that, and at the moment it's never array, an array of nevers, which sounds pretty weird. What does this mean? In the end, that's TypeScript's way of expressing that this here is an array of unknown types, and therefore will actually also never be able to tweak this, because if I, for example, try to set goals to an array of numbers, I get an error because I haven't defined which types of values should be allowed in this array when I initialized the state. So the general problem which we have to solve here simply is that when using React with TypeScript and when using useState in such projects, we have to tell React which type of value we're going to manage with useState. Sometimes it's able to infer this. If we would set this to some initial text, for example, it would then infer that goals is of type string. But for more complex types like arrays, which is, as you learned in the end, a connection of multiple types, the array and then the type of value in the array, in such cases, TypeScript, of course, is not able to infer anything. That's why useState is a generic function and allows us to add these angle brackets to pass this extra type information between those angle brackets. So in case of useState, we can use these angle brackets to set the type of value that will eventually be managed by that state. And here we can make it clear that this should be an array of course goals, which in the end should be objects with a title and a description and maybe also an ID, which we'll need later for deleting them. That's why I will add a new type here, course goal, which will have a title of type string and a description of type string, and then also, let's say, an ID of type number, maybe. And with that type defined, here between those angle brackets, we can say that the state we want to manage here should be an array of course goals. And as you learned, that's the syntax for defining that you want to have an array of a certain value. The alternative would be to use the built-in generic array type. One of the two must be used here, and with that, setting our goals to an array of numbers, of course, will fail, but now goals, on the other hand, is inferred to be of the correct type. And that now allows us to update the type accordingly as long as we do it in a correct way. So as long as we make sure that goals ends up being such an array of course goals. And that's therefore now how we should write the code in this handle add goal function. So to update this state here in handle add goal, I'll use this function form for updating my state, because the state will be updated based on the previous state snapshot. And as you also learn in my React the Complete Guide course, if your new state depends on the old state, you should use this special function form for updating the state. Because here you'll automatically get your previous state snapshot at the point of time where this state updating function here is executed by React. And then here in this function body, you must return the updated array in this case, the updated array of goals. Well, and here, where I want to add a new goal, that in the end just means that I want to spread my existing goals array into this new array. So I want to copy all the elements of the existing array into this new array. and then add a new object of that shape, to be precise, to the end or beginning of that array. So here I'll create it in a separate step to keep that code readable, and add a new goal constant here, which should be of type course goal. And I'm adding this explicit type assignment here to force me to set up a correct value here and to get better auto-completion, where the IDE now suggests these property names. So that's another use case for using explicit type assignments to get this extra safety so that I don't accidentally set up the wrong type, and to get that extra IDE support. And then here I can set the ID, let's say to math random, which is good enough for this demo project. Set the title to Learn React plus TypeScript in this case. For the moment it will be hard-coded. And set description to Learn it in depth, which of course means that at the moment we'll always add the same goal, but that will of course change soon. And with that, it's now this new goal, which is added here in my case at the end of this returned new state snapshot, so that new goals array that we're in the end setting up here. And with that, we can now finally use goals to dynamically output this list of course goal components. And that of course works just as you know it. We can use this goals state and then the map method to convert this list of course goal objects to a list of course goal components, for example. And for that, we pass a function to map, where we get our individual goal, and where we then return the element we want to output for every goal. And here I actually want to output a list item, and then in that list item, my course goal component. Because I will actually wrap that entire list with the unordered list element so that we get a semantically correct piece of code here. Now, what's really great about TypeScript is how well it's able to understand your code and infer types in different places of your code. For example, TypeScript understands how map works, and it understands that this goal, which we get as a parameter in this function here, will be of type course goal. Because TypeScript understands that this function here will be executed for us by the browser in the end, and that this value will automatically be populated, and that we will get the values of this array here. And since this array contains a bunch of course goals, TypeScript understands that an individual item of that array will be of type course goal. And that gives us extra type safety and great auto-completion here. For example, when setting the title, I can now type goal dot, and my IDE understands that I can now either access the title, description, or ID property. Because these are the three properties I set up in my object type here. And with that, we can output the title here, and then output goal.description here between the paragraph tags. And then on the list item, also add the special key prop, which React wants when outputting such a list, which should be set equal to goal.id here. And with that, finally, we can save that all. And if we go back here, we got this button, which we can press to output a bunch of course goals. Again, for the moment, they're all the same, but we got no error here in the console, no error in our code, and also not in the terminal, and we therefore now also know how to use state with TypeScript, and how we can make sure that TypeScript understands which type of value we want to manage here. So, slowly but steadily, this application is taking shape, though of course at the moment we're just working with some dummy data here. Before we're going to change that, I first of all want to make sure that this delete button works though. And I actually want to make my app component a bit leaner at least and outsource this entire list markup into a separate component. And that's therefore the first thing I'll do here. For this, of course, we can add a new component. The course goal list.tsx file could hold the course goal list component function. And you can now, of course, definitely also try creating that component function and using it in the app component on your own. The goal is to get this code into this course goal list component function. You can pause the video here and try it on your own. I'll do it together with you in just a second. So let's do that together. For that, I'll start by cutting this unordered list from the app component and returning it instead here in the course goal list component function. Now, of course, this component now needs access to the goals state. And we get that access, of course, with help of props. In the end, those goals are just props we should get here in this component function. Therefore, we can again set up our own type here, the course goal list props object. And as you know, you could also create an interface. And then here expect to get our goals. And the goals here should now be an array of course goal objects which have this shape. Therefore, of course, we can copy this shape and use that here and add square brackets thereafter so that it's actually an array of such objects which we want here, not a single object. With that, we can set our props here in that course goal list component to that props type we just added, and also use destructuring here to get hold of goals. And with that, we can then map through the goals again and everything works, except for this component where the import is missing. So now here we can import course goal, so this component, from course goal.tsx. And now this all works here in this course goal list.tsx file, and back in the app component file, we can get rid of this course goal import because we're not using this component here anymore, and instead import the course goal list component from the components folder and there the course goal list tsx file. And it's then this newly imported course goal list component which I want to use down here, and which now needs that goals prop, which should be set to that goals value. That value here refers to my state that I'm managing in the app component. This goals property name refers to the name I chose here for this property in my course goal list props object. So that's how this would work, and as you see, if I save this, the app still works as before. But this solution has a small flaw. And the flaw is, of course, that I copied this type definition. Now I have the same type definition in two places. Here in the course goal list component, and then also here in the app component. And that's bad. Because if I ever decide to change this type definition, because I also want to include an image or something like this, I have to change it in two places. And that's always bad. In programming, you always want to avoid situations like this. But there is a very simple, convenient solution. Because when using TypeScript, you can export types. I mean, we already saw how we can import types, like here, this props with children type, which I decorated with the type keyword, which is optional though. But that's how we can import types. Of course, we can therefore also export them. simply by adding the export keyword in front of the type that we want to export. And we could also export an interface, by the way, if you went for an interface instead of a type alias. So we can export a type like this, and we can now use one and the same type in multiple files therefore. We can use it here in the app.tsx file, but we can now also go to the course goal list.tsx file and import our type from the app component, so from the app.tsx file. The only problem we'll face here is that we now have a name clash because my type name, course goal, is the same as this component name. And that is not allowed. And even adding the type keyword doesn't change anything regarding that. That's just an annotation that helps the build tool get rid of unnecessary imports when it prepares the code for production. But it does not solve this name clash. Instead, to solve this name clash, we can use the same solution we would always use for solving name clashes due to imports. We can assign an alias to that import. So we can give this imported thing, this imported type in this case, a different name in that file into which we're importing it. For example, seagull or anything like that. And now it's that name which we refer to in this file if we want to use this imported type. So here, instead of manually repeating or copy and pasting this type definition, we can now use this seagull type here, so this imported type here in the end, as a type for our goals. Or to be precise, we make it clear that it's an array of such course goals, and that's then the type here. And that's the more elegant solution, because now we only define the type once and we then use it in different places.